Welcome back, class. Thank you for joining me for our continuation of section 4. So today, instead of just learning how to write rational exponents as radicals and radicals as rational exponents, we're actually going to be taking real expressions to these new concepts. So to begin, we're just going to take a number that has a rational exponent and we're going to simplify it. Okay? So let's take a look at this. So we have 16 to the negative 2.5. Now again, when we're looking at these, we don't want decimals. We want fractional exponents. So the first thing I'm going to do is I'm just going to say that that negative 2.5 is the same as negative 5 halves. Now, the next thing that we're going to consider is that that is a negative exponent. What does a negative exponent mean? Well, a negative exponent means it belongs in the denominator. All right, well, now for the new stuff. Now for the stuff of how do we actually calculate what that is? Well, the thing that I notice is I notice that half power, okay? 5 over 2 as an exponent. Well, we know what a 1/2 exponent does. A 1/2 exponent is the same as a square root. So really what this is telling me that I can do is I can take the square root of that 16 and turn it into a 4. And then I still have an exponent of 5 left. Okay? So that's how I would think of this. It's just if you see a fractional exponent, denominator of 2, if it's a half, well, that means you square root the number, and then the numerator of that fraction stays there. Because now we can take 4 to the 5th power and get 1024. And so that's how this would simplify. That's what this would look like as just an ordinary fraction. All right, well, let's try this again. So negative 32 to the 4/5 power. All right, again, the first thing that I'm noticing is that fifth there. All right, that fifth means we're taking a fifth root. So my first step is I'm going to take the fifth root of negative 32. And if you look at your power chart, the fifth root of 32 is 2. So the fifth root of negative 32 is a negative 2. Okay, so again, start by taking the root first. Once you've taken the root, now what you have left is something you actually know how to calculate. Negative 2 to the 4th power is going to end up giving you 16. So again, to me, that is the easiest way to think of these numbers. Take the root first, and then raise it to the exponent that remains. All right, now a little fun fact for you. So by converting radicals, or by converting radical expressions into rational expressions, we can now combine expressions even they have a different index. So in the previous section, if they had a different index, I told you you couldn't do anything. Well, there's a slight little caveat to that. Once you know how to convert it to rational exponents, now you actually can. So what we're going to do is to solve these problems. First, we're going to convert everything to rational exponents. That's why we practiced this skill yesterday, is because things work out better as rational exponents. Then, you're going to use the rules of exponents to simplify, and you can refer below to that. So, that concept bite day that we took, this is why we did that, because all those rules of exponents apply today, but now we have to apply them with fractions, which is something you haven't done yet. And then step 3, finally, if the original problem was in radical form, you want to convert back. In this section, you always want to answer the question in the form of the original problem. So let's take a look at what I mean by all this. So, what is the simplest form of each expression? Remember order of operations, you're going to want to simplify parentheses first. All right, so looking at this first one, well, remember, my first goal is I want to convert everything into a rational exponent first. So I'm going to convert this. So the fourth root of x cubed. Well, remember, the exponent goes on top, the root goes on the bottom. So that is the same thing as x to the 3/4. The bottom, the eighth root of x squared. Well, remember the exponent goes on top, the root goes on the bottom. All right, so now we have a division problem. So remember, when we are dividing two like things, we subtract the exponents. All right, now it's a little bit trickier here because you are subtracting fractions. So what I would do is I would type this into the calculator. You need to subtract those two fractions, type in 3/4 in parentheses minus 2/8 in parentheses. So 3/4 minus 2/8. Actually type that into the calculator. The calculator will tell you 0.5. So 0.5 is our new exponent. Now, again, we want to write them as fractions. So we know 0.5 is 1/2. So when you do that division, you're getting leftover x to the 1/2. Well, remember I said we have to answer the question in the form that it was presented to us. So because it was in radical form, we're going to convert this back into a radical. X to the 1/2 power, we should know, is the square root of x. And that will be our final answer. All right, our next one, same story. Okay, we want to take that and convert everything into rational form. So this is going to be 3 to the 1/2 times 3. And now 3 doesn't have an exponent here either. So it's just going to be 3 to the 1/4. The fourth root is the same thing as a 1/4 power. Now, rules of exponents. When we're multiplying like this, we're going to add our exponents. So, again, in the calculator, you can actually type in 1/2. Remember, multiplication means adding. So 1/2 plus 1/4. 1/2 plus 1/4. That's going to give us 3/4. Okay, so we end up with 3 to the 3/4 power. So again, in radical form, what does that mean? Well, that means that fourth is the root, that 3 stays as the exponent. So what we end up with is the fourth root of 27. And that's how you can leave this. Now you're finished. All right, for the next one. Well, the next one is a straightforward multiplying example. Okay? So again, what you end up doing is typing into the calculator. Multiplying means you're adding your exponents. So in the calculator, actually type it in, making sure that you're using the proper parentheses. And the calculator will give you, when you turn it back into a fraction, it'll give you 5/4. So this is going to be a to the 5/4. And this time you don't have to convert it because it was presented to you as rational exponents, so you can leave it in this form. So moving right along to our next one. Now remember what I said at the beginning. Think order of operations. So I'm going to simplify that fraction first before I even consider the exponent. I'm going to simplify the parenthesis. So 27 over 8 can't simplify, okay? That doesn't reduce. However, x to the 5 over x to the 2. Remember, when you're dividing, you subtract exponents. 5 minus 2 leaves us with an x to the 3. Y to the 10 divided by y to the 4, 10 minus 4 leaves us with a y to the 6. So again, to clean it up, the first thing that I did, just reduce the fraction. I combined those variables together because now I have less to worry about. So now I run through that 1/3 exponent is going to apply to everything inside here. Okay, so let's take a look. 27 to the 1/3. So basically the cube root of 27 is going to give you 3. X to the 3rd power. Well, power of a power you multiply. 3 times 1/3 will just leave you an x to the 1st. Y to the 6 to the 1/3 power. Power of a power, 6 times 1/3, or essentially 6 divided by 3, leaves you with a y squared. 8 to the 1/3 power. So basically the cube root of 8, you should know as 2. So once you run through it, that's actually all that you end up being left with. All right, moving on to our next example. So in this example, we have 9x to the negative 4, y to the 6, all to the negative 1/2 power. Now, there's multiple ways you can go about doing this. However, what I would do is I would just put that negative 1/2 into everything. So just like we did in the previous example, we're going to get 9 to the negative 1/2 power. Now, for the x, a power of a power, we're going to multiply. So negative 4 times negative 1/2 is a positive 2. And again, that y to the 6, we have a power of a power. 6 times negative 1/2 leaves us a y to the negative 3. So again, all I did is I took that negative 1/2 power and applied it to everything. Because now I can move things around. Anything with a negative exponent can come downstairs. So we get 9 to the 1/2 downstairs. The x squared can stay, and a y to the 3 downstairs. Now the last thing, I know what 9 to the 1/2 is, okay? I know that the square root of 9 is 3. So that's going to be my last step, is I'm going to get rid of that and just call it what it is. I'm just going to call that 3. And now that's the end of my problem. And our last example for the day. So again, the first thing we want to do is simplify parentheses. So the x squared divided by x to the negative 7, we can actually do that first. So remember, division means subtraction. 2 minus negative 7. Well, minusing a negative 7, remember that basically means you're adding 7. So this becomes x to the 9 to the 2/3 power. And now power of a power. So we're going to multiply that. So 9 times 2/3. You end up with x to the 6. And again, you can always use your calculator to help you with those kind of calculations. If you don't know 9 times 2/3 offhand, just do it with a calculator, okay? Let it help you. So I realize this is a lot to take in, a lot of different examples and different techniques to solve each one. So please, please, please make sure before you end this video, write down everything that I did. And then in class, we will be doing a lot more practice to make sure that you get really comfortable with this idea. So again, thank you for joining me. Make sure that you have everything written down, and I'll see you for class where we'll do some more practice.